Hi. Today we're going to talk about forces, which has been very much the subject this week. We've heard about, for example, if you have a block and it's on a rough surface, and there's a rope, and someone is pulling on the rope, then the rope exerts a tension force, pulling the block towards the person, and it also feels, from the rough surface, a frictional force in the opposite direction. Similarly, we've heard when we deal with molecules. So if you have one molecule over here and a second molecule over here, there is an intermolecular attraction. A force attracting the two to each other, for example, the London dispersion force, or dipole-dipole forces. So here's two types of intermolecular forces that attract molecules to each other. And today we're going to look carefully at two types of forces. First, we'll look at the electrostatic force. So an electrostatic force, if you've got two charged bodies, Q1 and Q2, and they are a distance r apart, then the electrostatic force is equal to Coulomb's constant, Coulomb constant, C, times the one charge times the second charge divided by the distance between them squared. If the two charges are of opposite sign, then the forces are attractive. And if they are of, here I'm putting both plus charges, the same sign, then the forces repel. There's a second way to look at electrostatic force, which is very useful if we're going to deal with uniform charged plates. Here is a charged plate that is uniformly plus charged throughout, and another charged plate which is uniformly minus charged throughout. So these are charged plates. And between the plus plate and the minus plate is the electric field. The electric field points from the plus plate to the minus plate. If you have a positively charged particle, it's attracted to the minus charge and repelled by the plus charge, and the force is this way. And if there's a minus charge, it's attracted to the plus and repelled by minus. It's proportional this way. It goes downwards, and the magnitude of the force obeys the equation. The electrostatic force is equal to the charge of the object, whatever the charge is here or the charge here, times the electric field. So these are two different ways of looking at electrostatic force. This one is for a pair of bodies, and this one is most useful when you're dealing with uniform plates. The last force we're going to look at is the most geometrically interesting. It is the magnetic force. And the magnetic force is, you have to have a north pole and a south pole. I put the north pole in front and the south pole in back. And there is a magnetic field that points from the north pole to the south pole. B, the magnetic field. And the magnetic force only exists for charged particles that are moving with a velocity. And when the velocity, if the velocity is perpendicular to the magnetic field, then the magnetic force is equal to Q, the charge of the particle, times V times B. So when the velocity of the charged particle is perpendicular to the magnetic field, the magnetic force magnitude is Q times V times B. And the most interesting part of the magnetic force is its direction, and we're going to need a pair of rules. For positively charged particles, we will need the right-hand rule. And I'll be doing the right-hand rule from my perspective, so it'll look backwards to you as you're watching this. And you're going to take your hand, and you're going to, three fingers like this will indicate the field direction, the forefinger will be the way it's moving, and the thumb will be pushing, it's the force. They're all perpendicular to each other. And I turn my three fingers, the field, in the field direction, which from my direction is like this. My forefinger now is pointing that way in the direction, from my direction to the force, and the magnetic force is pushing upwards. So if I've got a charge, if it's a plus charged particle, the magnetic force is upwards. Similarly, if I've got a minus charged particle, I will use the left-hand rule. And the left-hand rule is just like the right-hand rule, but with the left hand, three fingers now, they're in the direction of the field. The forefinger is in the direction of the velocity from my viewpoint, and the thumb is the direction of the force, which is pointing down. So here it's a minus charged particle that's moving, then magnetic force is downward. And the electrostatic force and the magnetic force are the two most important forces in chemistry. See you tomorrow.